This is an example of graphing an exponential function. Draw the graph of f of x equals 6 to the x minus 1. So how do we do that? First off, this is exponential. It's an exponential function. Now, what do I mean that it's an exponential function? Meaning x is in power, right? Exponents mean powers. And see how x is up here in the power zone? That's what it means to be an exponential function. X is up there in power zone. Now you might think something like x to the third or x to the sixth is exponential, but these are not exponential functions. Even though they have exponents, it's just numbers that are up in the power zone. X is in the base. That's not exponential. That's just a polynomial. But this is an exponential function because it not only has powers, but x itself is in the power zone. That's what it means to be an exponential function. And functions like that, what they generally look like, let me just give you the general look of an exponential function. Generally, if you have a function of that type, so let me write y equals a times b to the x. Generally, what it looks like is like this. It rockets up to the right, like that. And in fact, let me put something out here. Plus c. Let me make it. Actually, let me do this a little bit better for you. Let me put the plus c, and then what that c is the horizontal asymptote. There we go. There's the general look, and this is hitting at c. This is at a height of c. The c is the horizontal asymptote. So, in general, exponential functions have a horizontal asymptote, whatever the number added or subtracted off to the right is, and then they rocket up to the right. Now, they can be flipped. You can have exponential functions that go like this. And that would be when you have a negative on the x there. It flips it, or they can do it with some fractions. I'll be showing you that in the other examples. You can also have exponential functions that are flipped downward, like that, or, there's various looks. And so we'll talk about that. Let's just leave that off for now. So in general, exponential functions, the general exponential function, if it doesn't have any flips, and we'll talk about what makes them flip, it generally goes up to the right like that. That's the general look of an exponential function. It's like that. Okay, so let's do our particular example now. So ours is y equals 6 to the x minus 1. That f of x, remember functions, f of x, g of x, h of x, those are just y. That's by common agreement in the math science world. Function values are y values. Okay, so how do we graph it? Well, notice there's like a plus 0 out there. So the c, the number added off to the right, is not there, which means it's the same as adding 0. Do you see why I'm saying that? Adding 0 doesn't change anything, does it? And that way I have a number added off to the right to match up with the c. So that tells me the horizontal asymptote is going to be right here at 0. So that's the first thing they want us to do on this one, is realize the horizontal asymptote. Okay. Next, we need to graph some points. So how do we do that? Well, I'm just going to plug in whatever looks good. I usually just start with 0 because it's usually an easy number. It's going to do something a little strange here. We'll see. So plug in 0 for x. You're going to get 6 to the 0 minus 1. And that is 6 to the minus 1. Now, do you know what 6 to the minus 1 is? What do negative powers do? That's going to be very important in this chapter. It's understanding negative powers. That flips it and becomes 1/6. So notice it's a positive 1/6. It's not negative. So negative powers don't make negative answers. They flip things. They make fractions. Very important you know that. Any number to a negative power flips it. So that's not a convenient point. I'm not going to put that on the graph. I mean, I could. It's about right there, right? Over 0, up barely, a sixth. It's not going to be an easy one to graph. So I'm not going to do that one. Let's try another one. How about if we do 1? So I'm just going to go up by 1. I'm just doing 0, then 1, just because they're easy. Simple numbers. Let's try that. Plug in 1. Y equals 6 to the 1 minus 1, 6 to the 0. Now, do you know what that is? Anything to the 0 power is just 1. Are you aware of that? Anything to the 0 power is just 1. So you're going to need to know that. So very important rule. Let me just write that. Anything to the 0 power is 1, and anything to a negative power is 1 over the thing to the positive power. It flips it. It flips it. I don't want you to think of that as just some weird math rule that people made up. You just have to follow. That's not how math works. Math follows the truth. There ends up being rules, yes, but math is truth. What do I mean? Math is truth. What kind of truth led? That seems like it's made up. Let me show you real quick. I don't want to waste too much time, but I want you to see. What is 2 to the third? 2 times 2 times 2. 2 times 2 is 4 times 2 is 8, right? 2 squared. 2 times 2, 4. 2 to the first, 2. Okay, great. So what? So yeah, notice the pattern. What's going to come next? 2 to the third, right? 2 to the second, 2 to the first. What's next? 0, right? Now pretend you don't know the answer. How could you find the answer if you had no idea? You could just follow the pattern. Follow the yellow brick road, right? Follow the pattern. What's happening? We're going 3, 2, 1, 0 is next. What's the pattern in the answers? 8, 4, 2. What's happening every time? Divide by 2. Divide by 2, right? 8 divided by 2 is 4. 4 divided by 2 is 2. So do it again. 2 divided by 2 is 1. See? It has to be 1. Anything to the 0 power is 1. That's where that comes from because it's true. It fits the pattern. And what would be the next? What would be the next one? So follow the pattern. 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0, 2 to the negative 1. Right? I'm just following the pattern. 3, 2, 1, 0, negative 1. Okay? And then follow the pattern in the answers. 8 divided by 2 is 4. Divided by 2 is 2. Divided by 2 is 1. Divided by 2, 1 divided by 2, well, it's a half. Look at that. 2 to the negative 1 indeed is a half. See how it flips it down? Negative powers do flip things. It just fits the pattern. That's all math is doing, is observing the truth of the pattern. So, all right, enough with the reasons. Know these two rules well. 0 power is 1, negative powers flip things. Okay, so what? So now we have a point. Over 1, up 1. There we go. So there's a point over 1, up 1 that's going to be on our graph. Okay, so now how are we going to make this work? How is this going to fit with the graph? Well, we have 2 points. One of them we can't easily graph, but the other one we can, right? So let's do one more. How about? Let's go up to like 2. And let's plug in y equals 6 to the 2 minus 1. That's 6 to the 1. That's just 6, isn't it? So over 2 up 6. So there we have 2 dots. And of course we have that extra dot here. But 2 dots we can graph with the graphing tool. We already know the horizontal asymptotes at 0 because there's no number off to the right. We see that fitting with the dots, right? This dot, which is over 2 up 6, this dot, which is over 1 up 1. Even that dot, which is over 0 up a sixth. See how it's coming down like that? So the exponential function rockets up to the right. There we go.